So here's a fun fact for you, at least if you're using a Windows computer to do any kind of network work and you need to move around on a different IP address or something. When you are adding your IP address, if you have a need to put a subnet in, and most of the time you do, there's a little known thing that after you are done with the IP in the last octet, if you press the tab button once, it'll go ahead and drop down to the subnet, and it will fill in the default subnet for whatever class of network you've just entered in, A, B, C. If you don't know what those are, don't worry about it. We'll talk about network classifications at a later date. But point being that it's a nice little handy shortcut to get a subnet up and going quickly without having to type in every octet. Subsequently, if you show this trick to a colleague of yours who's been doing work on networks for years and never knew that in particular, they may become physically violent and attempt to attack you. Hello, welcome to Chaos and Controls, the show where we talk about modern devices, technology, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor. Today, I thought we could go ahead and continue our discussion on IP addresses by introducing subnetting and how to use it. Now, you may recall from a previous video that I described an IP address as containing information both about the network that I am on and the specific device ID that a particular device may have. And I posed the theoretical question of, well, how do I know which is which? And subnetting, as it turns out, is the answer. A subnet only has a handful of legal entries that you can use, and we'll get into why that is here in a moment. But if you've ever studied a handful of subnets, undoubtedly you've seen the number 255 come up a lot, but then you might see other numbers like 254 or 252, but you're never going to see 253 in a subnet. And let's go ahead and talk about why that is and what it means. So as I stated, the purpose of the subnet, which in addition to creating networks within networks, is really to help you separate out what is the network versus what is the device ID. Let's think about that for a minute. It's either the network or the device. It's one or the other. It's on or it's off. Starting to sound an awful lot like a binary number. So if we go ahead and say that let's make a 1 represent a number that is a part of my network, and a 0 represent a part that is my device, a standard Class C home network subnet looks something like this. Now, some of these numbers, hopefully all of them, are beginning to look familiar after some of the other videos, particularly 255, which expressed in binary is 8 ones. And we just said that 1 represents a part of the network. So, graphing this out here, what you can see is that my 192.168.0 are all a part of my network. And the last octet, this .0, all 8 of those zeros, are my individual device IDs. And remember, we said that a standard home network can host about 250 devices. And you'll notice that my last octet, the device IDs, we can go from all zeros to one full octet, or 8 ones, 255. So we have to reserve the .1 address, and we don't use the .0. And we also have to reserve .255. So that's 256 minus those 3 unique IDs. There are 253 devices we can put on a standard Class C network, like the one you're probably watching this video on. You'll also notice that since we are dividing between the network and the device IDs, the subnet, by definition, always has to be a series of sequential 1s followed by a series of sequential 0s. We will never see a 101 pattern in any subnet. Subsequently, if I start backing up this subnet, what you'll notice is that there's only a handful of legal characters, namely 255, 254, 252, 248, 240, 224, 192, and 128. Now, I'm cheating a little bit here because this is a Class C network, and a Class C network always has to have at least a /24, or in other words, 24 ones in the subnet. We can have more of them and divide down the network. Say you want to have the kids network and the adults network, or a controls network and a home internet network, something along those lines. But they always have to be one of these magic numbers, and that explains why you'll never see a 253 in a subnet, because it's got this pattern here. Now, writing out all these ones and zeros can get rather tiring, which is why in things like Windows devices you often see we use the decimal equivalents and do 255, 255, 255, But, as I've just alluded to, it's even easier to just count the number of sequential ones, and after my IP address I can draw a slash and the number of ones, in this case a /24. And there you have it. Now you know a little bit about subnetting. I appreciate everyone's time, and we will catch you next episode.